Well, greetings everybody. Let's look at another problem where we graph a parabola using the MyMathLab graphing tool. Okay, so here's my function, here's my equation. It is a parabola. I'm going to transfer that over to my whiteboard and I'll work out the details over here and then plot the graph over there in MyMathLab. So here's what I'm given, all right, and I notice it says to use the vertex and one of the intercepts. Okay, so first thing that jumped out at me was to find the vertex. And I remember from an earlier video that how you find the vertex depends on what the equation looks like, and parabolas can take equations of two different forms. Now, does this one look like that type, or does it look like this type? I was saying probably pretty obvious. It looks like this type. Okay, it's a number times x squared plus a number times x plus a number. In fact, a, the number with the x squared, multiplying the x squared is 1. I mean, you could say that that was 1x squared if you wanted to. The b is 3. It's the number multiplying the x. Plus c, well, I've got minus 4, so that's like saying plus negative 4. That makes c negative 4. So we're definitely dealing with this. Okay, now how you find the vertex when the parabola is given in this way is that you find the x and y coordinates individually. You find the x coordinate first as the negative b over 2a, or you might say the opposite of b over 2a, or a, b, and c are those numbers you identify in the equation. You find that first. That's the x coordinate. And how do you ever find the y coordinate if you know x? You plug the x coordinate in. That's what y is. In equations, in functions, you plug the x in, you get the y back out. So if you find the x like this, plug it into the equation, whatever it happens to be, and that's how you get the y. Not just for parabolas, but for anything, any function, okay? So let's do that. I take this to find the x coordinate. The formula is negative b over 2a. So I get negative 3 is b over 2 times 1 is a. And that just works out to be negative 3 over 2 because 2 doesn't evenly divide into 3. But I think for the sake of using the graphing tool, it'd be nice to have that as a decimal. So if you might know that that's 1.5, but if you take 3 divided by 2, you get negative 1.5. I think that's the most convenient number for us. That's the x coordinate of the vertex. What's the y coordinate? Plug the x in. That's how you get the y. All right. So I take my function and I put in negative 1.5. I get, look at that right there. You see that? That's going to be negative 1.5 squared plus 3 times negative 1.5 minus 4. I use my calculator to do this, and I got negative 6.25. So that's the vertex, x and y coordinates. We can find the vertex on this graph by going left 1.5 and down 6.25. Let's try to do that. I'll hold off on the rest of this problem for now and just do like this. Okay, so that point was negative 1.5 for x, negative 6.25 for y. To plot that first, I have to select what kind of graph am I dealing with. And there's a lot of options. We just need this one. It's a vertical parabola, meaning it either opens up or down. So I select that. Then I put that point in, negative 1.5. Notice how when I move around, the point appears up there. So, I could just track it like that. So let's see, negative 1.5, negative 6.25. Looks like I'm almost there. There it is. Okay. And I just mark that point, and I can see it's confirmed up there the way I want it to be. Okay. All right, now I can't really do the rest of it unless I find another point. It's not going to fully take shape unless I put another point on there. So let's do this. The question just said to use an intercept. The intercepts of a graph are either where it hits the x-axis or the y-axis. Okay, where the places it hits the x-axis are called the x-intercepts, and the places it hits the y-axis are called the y-intercepts. I think the y-intercept is easier to find, and it doesn't say which one we have to use. Let's just use the y-intercept, okay? So, how do you find the y-intercept? Now, the y-intercept is the point where the graph hits the y-axis. On the y-axis, x has to be 0 everywhere, no matter what. So we will always find the y-intercept by letting x be 0. No exception to that. Any function, anywhere, if you want to know where it hits the y-axis, you let x be 0 because x has to be 0 on the y-axis. So I take my function and I put 0 for the x and see what I get. There it is. I get -4. The y-intercept is 0 for x, -4 for y. Okay. So that should do it. Like, I just have to select one other point for this to take shape. You know, and that will be the one that I choose. 0 for x, -4 for y. That one will be easy to pick. It's right there, and I've got it. Okay, so this is the way I want it. I got my points where they need to be. It's taken shape, and I'll save it. There it is. I'll check it, and it's going to be right. Okay, what about the axis of symmetry? Well, all right, if you have a parabola, you know, whatever it looks like that, that's really sloppy. But the axis of symmetry is this line that goes right through the middle, okay? So it's like, I want some way to tell you what that is. I mean, I know I can see it right there, but I mean, how do I type in what it is? Since the axis of symmetry goes through the vertex, okay, then it's like, that's how we communicate what it is. And you might be tempted to say it's the x-coordinate of the vertex, and that's half right, okay? So the axis of symmetry is at -1.5. I mean, that's kind of right. I mean, it does go through the vertex. Specifically, it goes through like the x-coordinate of the vertex, all right? Okay, but that's not the entire truth, because the axis of symmetry, that vertical line that goes through the vertex that cuts the parabola right in half, mirror images on either side of it, it's a line. It's not a number. -1.5 is a number. X equals -1.5 is a vertical line. Vertical lines always take the form x equals a number, and that number tells you where the vertical line is along the x-axis. So that would be it. The axis of symmetry is not -1.5. It's x equals -1.5. In general, the axis of symmetry will always be x equals, and then you put whatever the x-coordinate of the vertex is. Okay, so that should be easy. You could do like that, x equals -1.5. And then it's correct. What about the domain? Well, the domain of a parabola is always -infinity to infinity. If you want to know the reason, well, the domain does signify all the possibilities for x. This graph will continue to go upwards forever. It will get wider and wider. It will cover the entire x-axis. It'll span the entire x-axis as it keeps going up and getting wider. So what I mean is, the reason why I say the function's domain is all numbers, or -infinity to infinity, is because, you know, that number is 4. It doesn't look like there's a point on this graph where x is 4, but this does keep going up. It does get wider, and if you could expand the graph, at some point there's a spot where x is 4. You could go up to it, or 6, or anything, okay? So the domain of a parabola will always be -infinity to infinity, okay? What about the range? Okay, so the range is all the possibilities for y. Domain is all the possibilities for x. The range is all the possibilities for y. I see from this one, it goes from this point up. You know, if I want to tell you the possibilities for y, if I want to tell you everything on this graph that y can be any number from whatever that is upwards. All right? How do I say that? Where's this point that's at the bottom? Okay, so what I'm trying to say is, you know, see, that's -7. That's not a possibility for y. There is no point on this graph where y is -7 or -8 or anything below that bottom point. Where's that bottom point? Well, that point is the vertex. It's left 1.5 and it's down 6.25. That point at the bottom is negative 6.25. So y can be anything from that point upwards. Okay, so our range is bracket negative 6.25. And why do I put a bracket around the negative? Why not a parentheses? Well, if I put a parentheses, I'm saying the negative 6.25 is not there, but if you go above it, it is. But that's not the case. That negative 6.25 is that point right there. It's on there. We have to include a bracket. All right. So negative 6.25 to, and I'll play a little game here. To what? 2? Is it 2? Is that how far it goes up? It looks like it. You look at the graph, it looks like 2 is the very top. But remember, this keeps going up. It's got no ceiling to it. It goes upwards forever in the direction that you see here. So it doesn't stop at 2. I know that it looks like it, but that's not the case. We have to use our imagination and remember that this goes up forever. Okay, so there's my range. All right, so the graph, the axis of symmetry, the domain, the range. We got everything that we need for this one. I'll recommend that you do this question this way. I suppose that, you know, when it says to find one of the intercepts, you could find some different points than I did, but I think for now it's best and easiest if you use the vertex and plot that, and then find the y-intercept, plot that one, and it will take shape from there.